This is a presentation which I've been doing for a while for people who are new to REST, and in particular new to REST in OCI. Okay, and the goal here is to kind of introduce you to the concepts of REST. So I'll talk to you a bit about first what's REST, the main concepts behind it. Then I'll focus on REST in our OCI products, and I'll explain why we actually moved to REST, what's different between REST and previous approaches we had that before. And then I'll talk also about the specifics of REST. And in particular, I think that if you want to understand any kind of REST API, you want to understand how to identify the resources in your system, how the resources are represented in the system, and then finally, what kind of operations you can do on those resources. If you have these three pieces of the puzzle, then you typically understand how to work with the REST API. So I'll go through that as part of this presentation. And then at the end, I'll just jump into a demo where I'll show you hands-on how to get started, where to start, what to look for, and then I'll show you a couple of examples of exercising the REST API, things that I actually covered in the concepts, and then I'll finish probably looking at a couple of sample code that actually makes use of this REST API. So let's start by REST. So what's REST? And REST stands for Representational State Transfer. That's what it stands for. So this was a term which was first introduced in the PhD, and you can actually follow the link and read the PhD actually. It's interesting, but the part where REST is introduced is just a small section of that PhD, but it made obviously big ripples and changed a lot the way people did things in terms of developing APIs. It's not the system. It's not the framework, it's not the library, but it's an architectural style. That's what's described in that PhD. So you will not just download something and be up and running, but instead you'll have an architecture definition with some desirable properties that you want to put into your APIs. That's what it is, right? And those constraints, those guidelines that you should actually follow for API are listed there. So the first one, client-server, which means that it's definitely the REST APIs or the REST approach enforces or promotes client-server architecture where you have a well-defined client separated from the server, making different calls, independent calls, right? So the independent systems completely. It's supposed to be stateless as well, and this is very connected also with the notion of HTTP, pure HTTP. So the idea here is that every request you make does not contain or does not keep state on the server. So why is that good? Well, for starters, in terms of scalability, you gain a huge capability of scale just because you keep the protocol, you keep the interaction stateless, right? You don't have to keep state on the server, so that reduces your footprint on the server side if you want to. Allows you also to let's say, clone the servers that are actually fulfilling the requests, right? Because you don't have to share state, so each one of them can do the request independently. So it's perfect for things like doing load balancing, where you can actually just say, the first request goes to one server, the second request goes to the second server. There's no state involved. It can actually scale easily, right? It's cacheable. So the idea here is that every single interaction you have with the server should tell you whether the response that's giving you back could be cached or not. Again, what's the point here? Scalability, again, efficiency, right? So if I tell you that something can be cached, next time you actually want the same information, you don't need to get it again, because I told you it can be cached, so I told you it won't change that much. So you can actually just hold on to that and then reuse that information instead of grabbing again from the server and putting some load on the server. A very important thing, I think, is that this architecture introduces a uniform interface. So that means that typically if you know one REST API, you'll probably know another REST API, the other REST API as well, because the notions of the interface that's introduced in REST API, they're common. Or at least they should be, right? Again, you often hear about REST APIs and RESTful APIs, and some people claim they have a RESTful API, and when you look at it, it's anything but a REST API. So again, and this is because this is an architectural guidelines, not the system. You typically just, if you follow the RESTful approach, you will recognize the patterns, you will recognize the uniform interface, but sometimes people don't, and that's the way it is, right? It's a layered system, or at least introduces the notion of a layered system, and the idea is that you're going to have several layers fulfilling several different aspects of your system. So, for instance, you might have a layer which is only responsible for doing the REST API interaction, the translation of web requests from and to the client. You might have another layer which is responsible for persistence in the database, right? And that allows you huge flexibility in replacing these layers without impacting the others. A good example of this, we actually did as part of OCI. We were storing all the performance data in databases or in MySQL, and in 7.0 we actually just replaced that layer completely by storing information into Cassandra. And the users of the system couldn't care less, and in particular even the REST API layer itself couldn't care less that it's being stored in database or in Cassandra, right? Because the system is layered, you can easily swap these layers. The last two I'm not going to go into much detail. They're actually described in the PhD. That I think they're less applicable to our discussion here of REST APIs, but you can go and take a look at the PhD description and read them. It's a good read. So this is what REST is all about, okay? First and foremost, again, like I was saying, the first thing you need to do or need to understand once you start learning one REST API is you need to identify resources. Representational state transfer, that's REST. That means that you're going to have state in the system. And the first thing you need to do is you need to know how to identify the different states that exist in the system. Typically in the REST APIs, states are identified by URLs. So you have one URL to identify each element that exists in the system. You have URLs for big collections, and then you have URLs for specific objects inside that collection. That's very typical. If you look at the top right, here's two examples of REST API URLs, identifiers, right? So the first one identifies a collection of users, and the second one identifies a user inside that collection. And this follows more or less the pattern we always find in REST APIs. You always have collections, and you have objects inside the collections. This is where I point out, for instance, often APIs claim to be RESTful. Typical REST API, you have a state for objects. So this is state-oriented. Some people actually build RESTful, I put air quotes here, RESTful APIs, where they have functional URLs. Functional URLs are not the pure REST URL APIs that you would look for, right? So the first thing, identification of resources. Typically in REST APIs, you identify them through your URLs. Manipulation of resources via representation. Again, the idea here is that every time you interact with these resources, whether it's just getting the data for the resources, getting the state for the resources, or just changing the resources, the state of resources in our system, you have to represent the state somehow. And REST APIs typically just use, majority of them, you can put whatever you want. Actually, I don't think the REST API guidelines tell you to use a specific format, but the most typical use of formats are JSON or XML. That's what you typically use. For all that matter, you could use text, free text if you wanted to just implement your own REST API. That would not be smart or wise, but you could, right? Yeah. So XML and JSON are the most typical used formats for representation of state. Self-descriptive messages, again, this is important in terms of what REST typically does. One of the things that we try to do, once we know what are the objects and how you identify them, once you know what's going to be the content, the messages coming back and forth on the server should be self-descriptive enough to tell you how you can actually read the content coming back from the server. Okay, so for instance, whenever you make a request to a REST API, the REST API should give you back the content, the payload, and should tell you what's inside. It should tell you that the format inside is XML or JSON, so that you can actually use the proper tool to process the content and make some sense out of it. You can use an XML parser, you can use a JSON parser, but the message is self-descriptive enough so you can actually do something with it, programmatically or manually, whatever you want, right? The other concept, which is highly associated with the content, with the payload of the representation of the object, is HATE-OAS, which I can never say properly. That stands for Hypermedia as the engine of application state. And what this means is that we try to have states, or REST API try to have states, which are descriptive enough not only to get the state of one object, but to get hints on where to look next. Think of it as a hypermedia, right? Web pages, whatever. every web page has the content of the page and then has links to other related pages. So HATE-OAS is exactly that the payload, the content, the representation of the state of the object not only has the content of the object, but also has other links to other objects that you might want to grab to get more information related to the first object, okay? And this leads to really powerful, scenarios where you can have your application being driven, completely driven by the content, so you can start crawling the system and grab all the information you might need, okay? Make sense? And then finally, for REST resources, typically the extraction of the resources from the system are done through, or is done through the HTTP protocol. Again, the HTTP protocol is widely used for REST APIs. I don't think it requires the REST API. I don't know if the REST API actually requires to, or REST API is required to have HTTP protocol as a base for communication, but I think every REST API I know of actually uses HTTP protocol for communication. Okay? So this is REST resources. Let's talk about verbs. So we know how to identify objects in REST APIs. We know that the content is going to be represented in some way, JSON, XML. The messages are descriptive enough to tell you what's inside. Now we need to know what can we do on those objects, what kind of operations we can do. And typically, REST APIs piggyback on the HTTP protocol and use the verbs which are available in HTTP protocol to apply semantics on the state. Okay, so you have posts. Okay, so most people know a couple of the verbs, but there's an immense number of verbs that are probably unknown to most people. Post, everybody knows. Get, everybody knows. Delete, maybe not so much. Batch, maybe not so much. Headers, options, there's so many of them. So the REST APIs use a couple of them. Post typically has the semantic of creation of new objects. Get typically has a semantic of retrieving the state of objects without side effects. So it should be read-only, no write at all. Delete should have the semantics of deleting objects from the system, states from the system. And then put should have the semantics of updating the state of an object. Patch, which I don't list there, is also a verb which is used with the semantics of updating the state of an object. The difference between the put and the patch is that the put implies that in pure REST APIs, it implies that you should be providing the full state of the object to update the object. The patch implies that you could provide just a partial state of the object to update only parts of the object. It's the main difference there. I point out, this is the pure REST approach. A RESTful API does not necessarily need to follow all these guidelines, can relax a couple of those guidelines, and often does so. I mean, it's crazy for everybody. That's my opinion. Not the statement, but my opinion. It's crazy for someone to try to follow all the rules completely to the 100%. You end up with a system which is completely unusable to some extent. That's my opinion. So some rules you can kind of relax a bit and let it slide a bit more. So again, the put in the post is a good example, the put in the patch. Sometimes you might just want to do a put which we don't require to actually provide the full state. You know, you can do that. So these are the verbs. This is what the kind of operations we can do on our REST. This is the kind of operations that REST uses to operate on the state of objects. Let's switch to OCI. Now that we know a bit about REST API, what it is and what you can do with it, let's talk about OCI. And here I'm going to give you a bit of history, a bit about this. Let's give you a bit of history, what was there before 7.0, and what we start doing with REST API, why we start using REST API inside OCI. So before OCI 7.0, we started by doing a system, a Java server. Actually, before that, we had clearly defined AWS Java UI, what we call the old Java UI, which is still there, but we're kind of replacing it gradually. So this is Java talking to Java, and we found out that the best way to do it, or the simplest way to do it then, was to just implement an EJB layer to have our Java UI talk to the server. That was fairly simple for us to do. It was the communication protocol that was suitable to make this work. What we found, however, was that customers started asking access to data inside our system, started asking for an API, and using an EJB API would not be the best approach to our customers. EJB API implies that the customers would have to use a specific technology, Java. Furthermore, inside Java, they would have to use EJBs, and they would have to learn about EJBs, which is not necessarily an easy learning curve, right? You would have to go through a steep learning curve to actually understand even how to get started. Well, that's complicated, right? So we decided at that point that let's provide something which is a bit more flexible for our customers to use. And then we introduced a SOAP API. And the SOAP API allowed our customers to be flexible enough to use whatever programming language they wanted to, as long as they were able to translate SOAP or translate their calls into SOAP API calls and get back the results and do something with it. So they could do that in Perl, Python, Java, whatever, right? As long as we have support, you could do it. And that was good. However, the fact is that we introduced here a duality of APIs. Now we had an EJB API, which was being used to serve our Java UI, and we have the SOAP API, which was used for our customers. And inevitably, the moment we have the redundancy, that means the APIs likely start diverging. So one of us actually goes in and adds a new feature. We add the feature to EJB API because we want this feature to be visible in Java UI. And we forget to add the SOAP API. So our customers start scratching their head and saying, hey, what's going on here? I see it in the Java UI. Why cannot get it? Why is it that I don't see it in my API that I can actually use and integrate into my whatever, right? So this is a bit of a problem. Worse than that, sometimes we fixed issues in the EJB API and we didn't fix them on the SOAP API. So sometimes even the same calls start producing different results, right? Or if we had performance enhancements in one side, we didn't see them on the other side. So this kind of was not a good situation to be in, okay? In addition to that, just using a SOAP API is not straightforward. If you want to use a SOAP API, you have to code. Seriously, you have to code. There's no other way around it, right? Good luck doing something else. So that means that the steep learning curve is that our customers need to start coding before they even start understanding our system. That's bad. So in OCI 7.0, we decided to introduce a REST API. And the idea here is that we use a single API to have both our new web UI talk to the system and our customers talk to the system, right? So there's a single layer, which means that if we need to enhance, we enhance in one place, our customers get our enhancements, our customers get new features and so on and so forth, in one single place to change, right? There's no more this divergence to code bases. In addition to that, REST APIs, if you want to start exploring REST APIs, you don't need to code. You can use the browser. The best tool ever for you to actually explore REST API, you can actually just start playing with it and understand the API even before you start coding, which is a big thing, I think, for anyone to understand an API, right? Understand it before you start coding. So this is why we added the REST API. We're eating our own dog food, so whatever pain we feel, we'll probably feel the pain before our customers even do. So you get to fix them before our customers even see them. So again, nice things about the REST API. This is why. Other reasons, again, the SOAP API was really hard to play with, and we decided that it was time to actually move away from that. Everybody uses REST APIs these days, so everybody that actually programs anything against an API is probably familiar with the notion of REST API instead of SOAP or something else, right? HTTP, easy to add. It's a very flexible API in the sense that you can actually add new features without breaking existing customers, which again is not something we could do with SOAP. In SOAP, if we added new attributes to the API, we would probably be breaking existing customers with the old versions of the API. With REST API, we don't need to do that. As long as we actually make sure that our changes are backwards compatible, as long as we only add attributes, we're not breaking the customer. The customer can still use old versions of the API client code to talk to our system without breaking. It's implementation agnostic, so they can use, they can use whatever they want: Perl, Java, Python, PowerShell. I mean, if there's a language you don't have support for REST for, you probably should not be using that language anyway, so that's fine. And then tool support. Like I said, if nothing else, the browser is a big tool that you can actually use to help you with REST API. But there's more tools that you can actually use. Postman, a great tool for you to troubleshoot things and troubleshoot and interact with REST API. I don't know, there's so many of them. So that's, again, another reason why we actually added the REST API. Now let's talk about the REST API itself. And now I'm going to focus on the things I talked generically about when I talked about REST APIs. We talked about identifiers. This is the first part I'm going to show you. So how do we identify the objects, the states inside our REST APIs? We got global collection URLs in our system, okay? And we got a couple of them. There's not that many. So we got the top level ones. This is where you start typically to actually explore the system. You got the collection for storages, for hosts, for virtual machines, for applications. There's a couple more, like data stores. and maybe applications. So there's a couple of them top level that you can actually get started. These are all documented. I'll show you them afterwards, and I'll show you how to get to them, to the documentation. But know that there's a global collections. That's where you start exploring the system. The URLs are fairly straightforward. They all are prefixed by REST, the specific major version, and then the section inside the version. This big section inside the REST API. So you're going to find, say, an assets sections for our assets. You're going to find an admin section for the administrative parts of our OCI application. These are the main big sections. Let's talk about versions. The version is explicit in the URL. That's intentional. So if you're talking with our REST API, you will know exactly which version of our API you're talking to. Versions are backwards compatible within the same major version. So for instance, we do have minor versions. So we start, right now we're at the published version is 1.2. We are about to release version 1.3 with 7.2, with OCI 7.2. If you build code for the version 1.2, that code should work against version 1.3 because it's backwards compatible. So we're not breaking compatibility there. If we have some breaking change, if we have something that we need to reshuffle and rework completely, then we'll introduce a major version, version 2. What does that mean? That means that your code might work against version 2 or might not work. We will not make any promise. Odds are that probably what you're doing still works. You'll have to check it, right? That's our compromise. That's our contract with our customers. Again, within the same major version, you should be backwards compatible. Besides global collections, you have the same kind of notions that we have in RESTful APIs. So you have individual object URLs, individual object identifiers. They're going to be identifiers inside the collections. So an example there, you got the storage. Inside the collection for storage, you have the ID, you tag the end, you put the end, at the end you put the ID of the storage you're looking for, and that's the identifier for your storage, okay? And then you have nested collections. The notion of nested collections is prevalent in REST APIs. So if you have an object which is supposed to have a containment relation with other objects, then you probably have a nested collection inside the objects. The example there is for storages. For that specific storage, you might have storage pools. So there is a nested collection for the storage pools which are contained in the storage. And that's how you access pretty much all the collections and objects for your system. So now we know the identifiers. Let's look at the payload. Let's look at how the state is represented for each of the objects. First of all, we represent our state in JSON. Okay, we decided to make an explicit decision not to support XML yet. At some point, you can actually start supporting XML. We've built prototypes which easily can swap between JSON and XML. But to keep it simple, we're just doing JSON. JSON is very easy to read, less verbose than XML. It's widely supported by programming languages, including JavaScript, which is what you're going to be using for any kind of web interface to this thing, right? So JSON is our decision. All our payload, all our representation of state will contain, for every object, will contain at least two attributes: the ID, which is our internal ID for the object, and a self, which represents the identifier, the REST identifier for the object, okay? That's the full URL. So besides the main top-level collections, which we looked at, we don't expect our customers to have to build URLs. We expect our customers to start exploring the top-level collections to get the URLs for those objects that they care about, and then explore those objects they care about by using these self URLs to get more information, right? So please, no building if you can, no building of URLs. You can, right? So besides that, our payload contains basic attributes, like here an example you have for storage. You have name, simple name, display IP, serial number, so on and so forth. You have a bit more complex attributes like raw capacity, which is an object in itself, which contains a value and a unit type. I'll show you documentation for this, but you should expect to get in the first part of our payload these basic attributes and maybe a bit slightly more complex attributes. After that, we go into the hate OAS land. So we're going to provide you enough information for you to go explore other related objects for the object you're looking for. So as part of our standards, every object has an expand, _expand section, which you can choose to display or not display. And this _expand section will show you other links, other URLs that you might care about. So in this example, for instance, you can look at storage nodes or storage pools, you have a URL here, which means if you do another call to this URL, then you'll get all the storage pools for the storage, right? So you can explore more. Now, that being said, developers, and me in particular, we're lazy, right? So I don't care about doing 2 requests. I don't like doing 2 requests. I want to do one as little as possible. That's developers, right? Mm-hmm. As little as possible is what I want to do. So instead of having to make 2 requests to get first the storage and then getting the collection of storage pools, I would like to make just 1 request to get the storage and storage pools. And this is where our concept of expansion, which is specific to our API, this is where our context of expansion in place comes in. So all these expand sections, they have not only the URL, but they also have an ID of the expansion: storage pools, storage nodes, performance, suggested resource results, right? So for any of these URLs, I can decide to ask to get the payload for the storage, and I can decide to ask to expand in place whatever expansion is available. So I can expand storage nodes, for instance, which means that as part of my payload, now I'm going to get also a storage nodes attribute, which contains a list of objects, right? So I can do 1 call and get everything in one go. Okay, this is an important concept behind our API, and I'll explore a bit more when I go into the demo. You'll see how powerful this can be to explore the data. Okay, so now we got identifiers. We know which identifiers we have in OCI. We know how the payload looks like. We've seen one, we've seen all of them. That's the nice thing about REST API. You'll probably recognize all the object contents based on what you see here. Let's look at the verbs. And no big surprise, we follow the REST API standard, the semantic standard. So we have post for creation of new objects, get for retrieval without side effects, put for updating existing objects. We do support patch. We've started supporting patch. Initially, we didn't because the version of the framework we're using for the REST API did not support patch, but latest version support patch, so we started introducing a bit more of a patch. Then the lead for leaking objects. All the right operations on the REST API are admin restricted. So we actually have restriction on those. Only an admin user can actually do changes to the system. Every user, every authenticated user can actually get information from the system. No? Excellent. So now I'll jump into the demo. Now we know, I think I went through all of that. We know how to identify. We know how the payload should look like. We know which verbs you can actually apply. Now, the next question is, as part of a demo, where do I get started? I mean, for crying out loud, I have no idea. We talked so much, but where do I get started? Documentation for our system ships with every instance of our OCI server, every one of them. So if you go to the little question mark there, you'll see that we have REST API documentation right there. You click on it, and you're going to see our REST API documentation. This is live documentation. First, what do I mean by live? Live interactive documentation. First of all, this is not just a PDF or a set of static HTML we generate from whatever. We don't maintain this as documentation. So this is documentation which is tightly tied to the code. This is auto-generated documentation from code. So if we change code, immediately documentation changes as a result. So it doesn't get stale as a PDF or static HTML pages could get. Right, that's the first thing I need to point out. Second, this is using an open source, okay, let me say it in one go. Breathing. Open source REST API specification language. What this means is that this uses a system where we define everything that you can think of about our API in an open source language. It's well defined. If you specify your language this way, you'll know everything about the REST API. In addition to that, we're using a tool on top of it, which consumes this REST API specification language and presents it in a graphical way. This documentation is called Swagger, okay? So it's live and interactive in the sense that you can actually not only see the documentation, but you can actually interact with the system, with a live system as you look through documentation. Let's look at an example. So in this documentation, I see which version of the API we're talking about. It's very clearly documented there, again, live coming from the system. We see the several sections. So here's a couple of admin sections. I can manipulate user, patches, licenses, data sources, and so on and so forth. And here are all my assets. Okay, for each type, you're probably going to have a section here that you can expand. Let's look, for instance, at users, which is rich enough to have all the operations. expanding on users, now I see I have all the URLs and HTTP methods that I can use to interact with the system to manipulate user state, right? So I can do get on this URL to retrieve all users. I can do a post on this URL to create a new user, and so on and so forth. But what does this mean? I still don't know what I'm going to get back yet. Let's open these guys a bit more and see that if I do a get on this, this is the format I should expect to get back. An ID, which, by the way, was introduced since REST API 1.1, a name, a password, email. Insight role, for instance, these are the allowed values, right? You know exactly what you should expect to get from this call. Furthermore, you should be able to see which HTTP status codes you might be able to get. You'll know since when you have this version, this in the system, and you'll know what kind of role can access these things. Finally, like I said, this is live documentation, so I can click here and actually exercise the REST API. So this was a GET call to this REST API, and this is live data. This is not still data. This is actually going against the server, getting back data and giving it back to you. So you can play with the system and understand how it works. This is a simple API, just a GET. Here's a post. We document pretty much what we expect you to provide. So I'm saying that if you do a post on this URL, and you provide the REST API payload body similar to this, of course, you change it to your needs, but if you provide something like this, then you'll be creating a new user. Okay? If you do, say, a get on this, and now look, there's something curly braces ID, which is again documented. Yeah. Look at this, it's required, and that means the ID of the user to retrieve. So I don't know if there's user one, let's try it. I tried to get the user one, and there's my user one. Okay, so all properly documented. So you can explore here. Let's look at storages, for instance. Storage is a bit richer model. And like I said, user is good because it shows all the operations. So you can see the operation documentation of the post and the put and whatnot. Let's look at storages, which are a bit more involved, more complex objects. So let's go to asset storages. A lot more to deal with. Let's look at storage themselves. If I retrieve all storages, what should I expect to get back? No big surprise, like I said, the payload, the first starts with the basic attributes, which are all documented here. Some of them are simple, like this one, simple name, or IP is a string. Some of them are more complex, like capacity. Well, it's a storage capacity. What is this? Let's click on it and see. Oh, it's a description, a unit type, a total, which is more complex, and storage pools, which again is a capacity item. What's a capacity item? Let's click on it. It's a value, a height threshold, and a breakdown, right? So you can explore your documentation as much as possible by following these links and understanding even before you interact with the system. Furthermore, we talked about the hate OAS and the notion of expansions. The basic attributes are documented, but so are the expansions. And here are the expansions. You can expand on, say, storage nodes, and you will be getting back a list of storage node, which is this, which again is another object by itself. So you have the basic attributes and other objects, which you can keep going as much as you can. You get the idea, right? So you can explore the documentation even before you actually interact with it, with the system. And here's documentation of all the attributes explaining what they mean, right? So this is one thing you can do to get started. Let's play a bit with the API itself, and then before we jump into something else. Okay, so let's play with the API. I'm going to go localhost, and I'm going to start with one of those top level collections we talked about. REST v1, v1 assets storages. Right? So this gives me back the REST API, the payload for all the storages. No big surprise there. I'm going to pick the first one. I'm going to grab it. Okay, I'm looking at one storage. As someone who's exploring the REST API, okay, I understand all this stuff, microcode, capacity. I said this was more complex. I saw the documentation, right? This is actually a list of protocols. It was documented as well. Let me understand what else can I get related to this object. So I'll go, look, documentation tells me that I can expand on a whole bunch of things. The first thing I can expand is on this, underscore expands. Okay? So if I do question mark expand equals underscore expands, boom, I get information on everything I can expand. It's kind of the entry point for drilling down, understanding the model. Most of the time, if you're using an API, you don't care about it. That's why we decided not to expose it by default. Bandwidth that you save by not doing that is immense. But if you want to explore, this is how you explore. Now I know that I can expand on storage pools, right? So I'm going to say, okay, I want expands and comma separate. I also want comma separated. I also want storage pools. Great. Now if I scroll down, I got this in my expansion section. Here are my storage pools in one go. Now, storage pools are objects by themselves, right? So at the bottom of storage pools, you'll find the expansions for the storage pools. That means the storage pools, for instance, can expand on volumes. So what if I want to get, for this storage, I want to get the storage pools, and for each storage pool, I want to get the volumes inside the storage pools. Well, we have the concept of going deep in our expansions. So I can go to storage pools and use dot notation to go deep. So I can say, inside storage pools, I want to expand also the volumes. And now I am getting the storage pools, right? There's a storage pool here, sorry. Storage pool. Let me get rid of the expands. Expands become, see, this is when you know you're looking for it, becomes a lot harder to read. Here's a storage pool, right? One storage pool. And inside the storage pool, you have the volumes. And you can keep going and going and going and going. You can go deep as much as you want. Now I want to get, for the volumes, I want to get performance. And now I got the storage pools. Inside the storage pools, I got volumes. Inside the volumes, I got performance. So I can go deep. I can also go wide. So I can do, say, I want the storage pools, and I want the storage nodes. Now I'm grabbing, this guy doesn't have storage nodes, but it would retrieve the storage nodes side by side with storage pool. So it's really powerful, and I can go as wide as I want, and I can go as deep as I want, okay? Now, same concept. Let's look at performance. Performance are very special beasts, so I want to show them in particular so you can understand how you can retrieve performance from the system. So once I know that I have performance like this storages probably have performance. So let's expand on performance. Again, it's an expansion. Here's performance for my storage. There's performance. There's the URL for performance if I want to retrieve just performance. Okay. I got cache hit ratio. Again, this is all documented. If you look at storage performance object, you'll see what's available. Let me show it to you. If you look to performance, where's performance? There we go, performance, storage performance. I'm telling you, I'm going to have latency, IOPS, throughput, cache utilization, cache hit ratio, write pending, right? All documented. When you get here, here's my cache hit ratio. My cache hit ratio has read, write, total, and so on and so forth with specific values of current, min, max, average, sum. All the aggregations you can think of, they're there, built for you. For this specific start date, for this specific end date, for this date range. Right now, I'm not restricting on end range, on any kind of range. Here's my unit type for this read. Here's my description for the read, okay? And so on and so forth, right? I got all the metrics that I can care about for performance right here. Now, performance is, surprise, surprise, an object in itself, which means I can ask for expansions on the performance, and I can expand on history. So if I do now, I go deep and say expand on performance.history. If I scroll down all the way, now I'm getting a lot more. History will give me all the counters that we store in Cassandra back as JSON result. So here's all my counters in Cassandra represented as a map. It's actually a list where the first entry here is going to be the timestamp. And for the timestamp, I have all the counters we stored in Cassandra for that specific storage performance. Make sense? Yeah. So that's how you get started. I wanted to show performance because performance is a very special beast, right? Now, another thing we have as part of our API, and this is very relevant for performance, is that we allow you to filter on time. Right now, I haven't filtered anything on time, but I can specify two attributes, the from time and the to time. I'm going to do something silly right now. Okay, this is very silly, but just to kind of show you what I'm trying to do here. So the from time and to time are timestamps. So they're the milliseconds, the epoch. But if you specify the from time and to time, then the performance you're going to get back is going to be filtered on that time range. So of course I did something silly. From time 0 to 1, 2, 3, that's really no range whatsoever. So surprise, surprise, there's no aggregation whatsoever. You get back nulls. And then the history, there's no history. But again, it's possible to do that. You have all the tools to do it. The from time and to time applies to everything that you get. So if you go deep on any object, if, for instance, I get for the storage pools and the volumes and the performance, and if I go wide on getting a performance also for the storage, then the from time and to time is going to apply to the performance for the storage and the performance for the volumes. So it applies for everything that applies for the single call. Okay? So that's a quick overview of the playing with the API on the browser. Again, look at how powerful REST API can be. I'm using the browser to actually explore the REST API before coding. The next question is then, how do I code? How do I get started with coding? And for that, let's go back to documentation. The documentation page, which I like it to call it kind of REST API Hub, REST API Documentation Hub, has a lot more information than just the REST, the sections and the URLs and the methods and whatnot. If you drop down here, if you make this drop down, you get a couple of links. The second one, the getting started, is a PDF which contains the kind of description I've been doing here about the concepts of the REST API. They're all in the PDF. So if you download the PDF, you should have the description of, the payload, the basic attributes, the expansions, all that stuff. It's described there in the PDF. That one can be static because we're talking about concepts that don't change. The second link, which is actually the first on the list, is a zip file, or download a zip file, which contains our samples. And these are samples which the idea here is to very quickly show our customers what they can do with the API. Okay? Once you download the zip file, okay, it's probably downloaded here. Okay. It's still downloading. Okay, let's bypass this. Once you download the zip file, you'll get to a directory which contains Python and PowerShell. We do not ship, for our customers, we don't ship yet JavaScript example, or anything but PowerShell and Python, okay? We are, at this point, for 7.2, working on providing Java samples, very simple Java samples to show what our customers, what they can do. The guiding lines for our samples was to show one example across all the languages we want to support. So there's going to be a basic example on all our languages. One basic example for Python, one for PowerShell, JavaScript, Java, and so on and so forth. It's the same example. So the idea is that you can see how you do one thing in Python, you will see how to do exactly the same thing in Java and PowerShell and whatnot, right? That's the idea. It's a very simple example. In this very simple example, the goal is to display, to interact with the REST API to retrieve all the storages, inside all the storages, retrieve all the storage pools, and display the capacity for the storage pools for the storage. Just provide a simple report, okay? The main driver for examples, more complex examples are done in Python language. Python language, why? Python is very easy to read, less verbose than, say, things like Java. So we provide these examples in Python. The most complex examples they provide in Python. And then for other languages, just provide a basic one. Okay, so if you drive into each one of them, you'll find a README file that explains what you need to do for the samples to get the samples running, and provides also the list of the examples which are available, what they do. Okay, so let's look at a couple of them to see how easy it is to interact with REST API. So if you look at the basic example, this is the basic example written in Python. Okay, so here's the main. This is the entry point, okay? We're parsing the command line. From the command line, we're extracting a URL, a user, and a password. Okay, URL of the server we're talking to, credentials to talk to the server. Then we're calling this, we're calling this method with this variable, which uses OCI REST. So for some of our languages, we provide kind of a bare bones SDK, let's call it that. A couple of classes which should help you get started without having to understand lots of interactions with REST APIs. These classes, in particular this one for Python, deals with things like dealing with the basic authentication through HTTPS. It's what you do. You don't do anything but HTTPS. So this takes care of all the authentication, keeping state across calls to the API, and so on and so forth, right? State, by state I mean things like cookies, nothing else more than cookies, right? Like I said, REST API is stateless. So it's just a cookie, authentication cookie that gets kept. And it takes care of doing things like abstracting the puts, the gets, the posts, and whatnot in simple methods parsing the result back from parsing the results or generating results into JSON, parsing the results back into JSON so you can have a very simple interface. So once we have this guy here, just doing this takes care of doing authentication, then I can actually go to the main method that does something. So what am I doing here? Again, I'm doing a get, very clear, on assets storages. I don't care about version at this point. I don't need to specify. If I want to, I can do /rest/v1/assets/storages. If I don't specify an absolute path, but instead a relative path, then this OCI REST class takes care of prefixing with the rest, with the right prefix, REST v1, because it knows it's talking to version v1 of the REST API by doing the handshake with the server. So right now when I'm doing the get, I get back storages, actually storages. I'm looping through all the storages, and for each of the storages, I'm printing out the storage.family and the storage.name. We know the JSON. We know the JSON has family and name, so we're printing it out. Then, remember we have that self attribute in the storages? So I'm doing, in the storage, I'm doing a call, I'm doing a get call, okay, on the self of the storage and concatenating at the end storage pool. So now I'm looping through all the storage pools that I get back from that, and I'm printing out I'm calculating capacity based on capacity total value documented divided by 124, so converting from megabyte to terabyte, and then I'm printing out the pool with the name and the actual capacity. So the example very clearly just going to print out storage and then underneath storage pools with capacities. Yeah. That's it. In a couple of lines of code, right? We have 30 lines of code here. Most of them are spaces, and you can actually show interaction with the server. It's a very simple interaction. Again, lots of examples in here. You have things like licenses, how to interact with licenses, creating licenses, and so on and so forth. We have examples for, I believe, users, how to create a user, right? So all the examples are shown here. Very simple examples, right? This shows how to create a user. This shows how to delete a user. Actually, just shows how to create and delete a user. You got the idea. There's lots of examples here that show, at least our goal here is to provide some very basic examples that might be useful to people. So for instance, create user. Often our customers have several servers. So one thing which is often they will want to do is they want to create a new user in several servers at the same time. Right now, before REST API, they would have to go, I don't think you could do this with the SOAP API. You would have to go to each of the servers and go through the web UI or whatever and create the user one by one, right? Pretty annoying thing to do if you have 14 servers. You have some customers which have a fair amount of servers. So now you can script it. I can actually build a Python script that takes as input the list of the list of hosts. My hosts can loop through the hosts and go and create all the users in one go. And this is just an example. You can do the same thing for creating licenses, updating licenses, updating, I don't know, LDAP configurations, or all that kind of manipulation, creating patches, uploading patches to the system of data sources, creating data sources, checking on status of data sources. All this is scriptable and highly useful, I think, if you have a big environment, right? Not even to talk about integration, right? Again, one big use for REST API is integration with third-party systems. Things like extracting all information we have from the system and putting this information in things like an external CMDB database specific to a customer, from which the customer can do something like run their own reports or provision from this system. We integrate right now, for instance, with the WFA, so we're actually using the REST API to extract information from the system, to put it in WFA, so we can actually do automatic provisioning of volumes, internal volumes, from fresh data coming from the OCI. So I guess that's it. I think I'm right on time. So I think I went through all I wanted to talk about. Bottom line, I think we covered a lot. I talked about REST, generic REST, then I talked about REST API in OnCommand Insight 7x, our URLs, how to look into our system, what the payload looks like, what verbs you can actually do. Then I went into a demo where hopefully I'll show you how to get started, how to understand documentation, how to play with the system just using a browser and understand how the system works, how it is structured, and then finally how to get samples and get started with programming if you need to.